Welcome to the DIY Honda Garage channel. The DTC P219A indicates an air-fuel ratio variation of the cylinder, which is a significant issue that can compromise the vehicle's performance and emissions control. The air-fuel ratio is essential for efficient engine operation, as it ensures that the amount of air and fuel entering the engine is optimal. Specifically, this code points to potential imbalances in the cylinder's combustion process, which can lead to increased emissions and reduced engine efficiency. Responsible components include the air-fuel (AF) sensors that monitor the mixture and send data to the engine control module (ECM) for adjustments. Typically, these sensors are located in the exhaust system, just before the catalytic converter, allowing them to accurately gauge the exhaust gases. Before diving into troubleshooting, it is crucial to check for any concurrent DTCs, as addressing those first could resolve the P219A. This ensures a comprehensive approach to the engine's diagnosis and repair. The error P219A specifically relates to an air-fuel ratio variation occurring within a cylinder in the engine. The key components involved include air-fuel ratio sensors that are tasked with monitoring the proportion of air to fuel entering the combustion chamber. These sensors are critical for ensuring optimal combustion and are typically positioned within the exhaust system. The engine control module, ECM, is an essential unit that processes the input signals from these sensors to adjust fuel delivery. The problem can often stem from a combustion cylinder itself, potentially causing a misfire or a decrease in engine efficiency. The location of these sensors is vital. They are situated before the catalytic converter, where they can effectively monitor the emissions output. Thus, a thorough understanding of these components will facilitate accurate troubleshooting. Several factors can contribute to the occurrence of DTC P219A in the Honda Fit. One probable cause is a faulty air-fuel sensor. If these sensors are unable to accurately gauge the air-fuel mixture, it leads to imbalances in combustion, resulting in the variation noted in this error code. Another issue might be related to the fuel injectors. A malfunctioning injector may not deliver the correct fuel amount to the cylinder, thus affecting the air-fuel ratio. Compression issues can also lead to this DTC, as each cylinder must have uniform compression for optimal performance. Additionally, improper valve clearance can hinder engine efficiency, causing complications in the air-fuel ratio across cylinders. Each of these causes must be methodically ruled out to pinpoint the root of the issue. When DTC P219A is triggered, several symptoms may manifest that indicate underlying issues with engine performance. One of the primary signs is a noticeable decline in engine performance, which can include reduced acceleration or responsiveness. Drivers may also observe an increase in emissions, as an incorrect air-fuel mixture often leads to a higher output of pollutants. Additionally, the engine may experience misfires, a condition where the combustion process does not occur as intended in one or more cylinders. This can lead to uneven power delivery and rough idling. Lastly, the check engine light will be illuminated on the dashboard, alerting the driver that the vehicle's engine management system has detected a fault. These symptoms together signal that immediate attention is required to prevent further complications. The first troubleshooting step for diagnosing DTC P219A involves initiating the vehicle's engine management system. Begin by turning the vehicle to the on mode without starting the engine. This allows the Honda Diagnostic System, HDS, to perform necessary checks. Once in on mode, record crucial parameters such as vehicle speed, engine speed, manifold absolute pressure, MAP, engine coolant temperature, ECT, accelerator pedal position, APP, and air-fuel feedback, AF/FB values. These parameters provide a snapshot of the engine's operational state. After logging these parameters, start the engine and hold it steady at 3000 RPM. This should be done without load, ensuring that the continuous variable transmission, CVT, is in P or N, or manual transmission is in neutral. As the engine runs, conducting the cylinder air-fuel test 3 times within the specific HDS inspection menu will allow for an evaluative baseline to determine if the air-fuel ratio is within acceptable limits. In the second troubleshooting step, performing a test drive is essential to verify the diagnostic outcomes under real driving conditions. Using the recorded parameters from the prior step, drive the vehicle to facilitate dynamic testing of the cylinder air-fuel ratio performance. During this drive, closely monitor the onboard diagnostics (OBD) status for DTC P219A on the HDS. The OBD system provides vital data regarding the functioning of various systems and detects any faults. If the HDS indicates a failed status for DTC P219A, it confirms the issue has been reproduced. However, if it shows a passed status, this suggests that the system is functioning adequately at the moment. In cases where it reports an executing or out-of-condition status, further investigation is warranted to determine the discrepancy. The aim here is to establish a clear understanding of whether the air-fuel ratio variation is persistent or intermittent. For the third troubleshooting step, turn the vehicle to off mode to safely initiate an engine compression check. This step is critical as engine compression directly affects the effectiveness of combustion within cylinders. Use a compression tester on each cylinder to assess the pressure levels. If any cylinder exhibits lower compression than its peers, it is a clear indicator of potential mechanical issues, such as valve sealing problems or worn piston rings. Should a compression issue be identified, addressing this will take precedence to restore proper engine performance, and necessary engine repairs should be made to rectify the compression disparity. Conversely, if all cylinders show uniform compression levels, this indicates that the next troubleshooting step can be pursued with confidence, as there are no engendering problems concerning compression that would lead to variation in the air-fuel mixture. In the fourth troubleshooting stage, focus shifts to inspecting the valve clearance of the engine, as proper valve clearance is crucial for optimal combustion in each cylinder. Valve clearance refers to the distance between the valve stem and the rocker arm or camshaft when the valve is closed. Incorrect clearance can lead to valves that do not open or close at the correct times, directly affecting the air-fuel ratio and combustion process. Use specific measuring tools, such as feeler gauges, to determine if clearance is within specified tolerances. If measurements reveal that valve clearances are off, appropriate adjustments must be made to ensure that intakes and exhaust valves function correctly. Maintaining proper clearance prevents further complications that could lead to air-fuel ratio discrepancies and improves overall engine health. The fifth troubleshooting step re-engages the cylinder air-fuel test once more using the HDS after any adjustments performed in the previous steps. Begin by starting the engine and holding it at 3000 RPM without a load, similar to previous testing conditions. This controlled environment allows for a precise evaluation of the air-fuel mixture. Ensure that both the air conditioning and electrical loads are minimized during testing to provide an accurate reading. Conduct the cylinder AF test 3 times in the HDS inspection menu to derive consistent results. If the test outcomes show that the air-fuel mixture is now within acceptable parameters, then it can indicate that previous adjustments successfully addressed the issue. In cases where results still indicate a fault, further investigation is warranted in the following troubleshooting step. In the sixth troubleshooting step, Turn the vehicle off to safely perform an injector check. The strategy is to isolate the injectors, specifically by exchanging the injector from the problematic cylinder with one from a cylinder that is known to be functioning correctly. This eliminates the variable and tests whether the injector itself is at fault. After making the swap, restart the engine and hold it at 3,000 RPM without load, adhering to the same testing conditions previously established. Conduct the cylinder AF test 3 times to evaluate the new installation. If the results indicate a failure now located in the cylinder where the injector was transferred, it confirms that there is an injector problem. Consequently, replacing all injectors as a set is advised for consistent performance across the engine. However, if no failure is indicated, it suggests that the problem lies elsewhere, necessitating the next step. The 7th step entails a visual inspection of the exhaust gas recirculation (EGR) line, an integral system that redirects a portion of the exhaust back into the engine's intake to improve efficiency and reduce emissions. The EGR system can sometimes become clogged with carbon deposits or sludge, which could hinder its operation, thus affecting the air-fuel ratio. Check the EGR line carefully for any visible signs of obstruction. If any carbon or sludge is detected, cleaning the intake manifold EGR port, EGR pipe, and the passage inside the EGR valve using throttle plate cleaner will help restore function. Properly maintaining the EGR system is crucial, as blockages can lead to worse engine performance and problematic emissions readings. If no carbon buildup is detected, you can proceed to the next troubleshooting step. In the final troubleshooting step, a thorough check of both the intake and exhaust manifolds must be conducted. Over time, carbon deposits can accumulate, which would affect not only airflow but also the vehicle's overall performance. Examine both manifolds for any noticeable carbon buildup. If carbon deposits are found, this necessitates further checks for potential engine oil leaks, as these could contribute to the deposit formation. Cleaning both manifolds and ensuring they are free from obstructions will improve airflow and enhance engine efficiency. If no carbon buildup is found during the inspection and intermittent failures still persist, it may indicate a temporary fault that should be monitored over time for further analysis. Taking these preventive measures will help safeguard the engine and maintain optimal performance. After completing all troubleshooting steps for DTC P219A, a test drive is crucial for verifying that all repairs have been effective. This involves driving the vehicle under typical conditions and monitoring the systems closely for any symptoms that could indicate ongoing issues. The main goal is to confirm that the air-fuel ratios are now balanced within the cylinders, and that any previous symptoms, such as rough idling or misfiring, have been resolved. During this phase, keeping the HDS connected can help quickly identify any DTC errors or warning signs that arise. It is essential to observe the results from the onboard diagnostics, ensuring the vehicle maintains optimal engine performance and emissions control. If everything operates smoothly without any recorded errors, it validates that the repairs have successfully addressed the fault. Preventive maintenance is key to avoiding recurrence of DTC P219A in the future. One important strategy is to regularly inspect air-fuel sensors to ensure they are functioning as they should be. Any signs of wear or corrosion could lead to inaccurate readings that affect engine performance. Additionally, it's advisable to conduct routine cleaning of the fuel injectors. This can help prevent clogs that disrupt fuel flow, thereby ensuring efficient combustion. Equally important is monitoring valve adjustments to maintain proper clearance, as this can directly impact engine response and air-fuel mix. By incorporating these proactive steps into regular vehicle maintenance, owners can mitigate risks and ensure the Honda Fit runs optimally for years to come. In conclusion, addressing DTC P219A is a multi-step process that revolves around understanding the critical balance of air and fuel within the engine. It is imperative to conduct systematic troubleshooting to accurately diagnose the root cause of the air-fuel ratio variation. Each step in the troubleshooting guide acts as a foundation to identify potential faults and rectify them. Moreover, placing a strong emphasis on preventive maintenance can greatly reduce the likelihood of encountering this DTC in the future, saving both time and resources. By ensuring that all vehicle systems are regularly checked and maintained, Honda Fit owners can enjoy enhanced performance and longevity from their vehicles. Prioritizing a thorough understanding of these components empowers car owners to take proactive steps in vehicle care. Please like and subscribe to the channel. See you next time.